Hi, this is the first of the series of a video which I intend to create on how to solve problem sum using Singapore Max Model method. Okay, for those who know, I've been creating videos based on the question that you are provided on certain Facebook pages, which I no longer be able to post. As I create more and more such video, I realize it's quite repetitive, and instead I'm thinking, can I teach you how to solve problem sum using model method by yourself? Okay, instead of giving you the solution, I'm going to teach you how to solve it by yourself. Okay, I may not do it well, so do provide your feedback as I want to make the video useful to you. Disclaimer, as usual, I'm not an educator nor a trained teacher. The material in this video is based on my own understanding of the subject while I coach my own children when they were in primary school. Okay. So first, what is Singapore Max Model method? I know most of us knows about algebra, but what is Singapore Max Model method? I got it from ChatGPT. It's a visual problem-solving strategy used primarily in Singapore primary school curriculum. It's a way of representing mathematical relationship and concept using bar model, which is a simple rectangular bar, to help students to understand and solve words problem easily. So how it works, okay? Instead of jumping straight into the equation, okay, student will draw the bar to represent the known and the unknown quantity in the work problem itself. And this will help them to see the relationship and think through logically, visually before performing calculation. Okay, so this is the last part that is very important because I think a lot of you or a lot of us tends to straight away use the algebra method and jump into conclusion. But as you can see in those videos that I created, the moment you draw out the bar itself, the model, actually the solution is already there. So let's start the lesson. Okay. So I call it the lesson 1. Okay. I will give you some basic concept on what is max model method using some simple example. So for example, if we have a statement, John is 5 years old and his father is 30 years old. Okay, it's a simple statement. How do we draw a model? Okay, so we use F to represent the father. You use J to represent John. So you need to identify how you want to represent the character in the question. I can represent it in 30 years old by putting a long bar and call it 30 and a short bar and I call it 5. This is one way of representing the model. I can also represent it in another way, father and John, and I still draw a long bar, I do a short bar here, and just label this whole bar and call it 30, and this is 5. Either way is fine, whichever you're comfortable with. Okay, but the important thing is remember under the max model method, visually, after you draw the model, there is a lot of information that you can derive from the model. So what can we derive? From the model, you straight away can see that they are different in age is 25. Okay, the model also tells you that their total age is 35. So once you draw the model, straight away you can derive such information out from the model. Okay, instead of John is 5 years old, father is 30 years old, and you say, oh, I take 30 and minus 5 to get 25, which is visually you can't see it. But the moment you draw it out visually, it becomes very clear. Okay, so this is the power of model methods. Okay, let's move on to the next example. Okay, same thing. John is 5 years old and his father is 6 times as old as John. Okay, so now you're going to the next step. Instead of giving you the exact age of the father, he tells you that his father is 6 times as old as John. Same thing, you go for father and John. So now John is 1 unit and you know John is 5 years old. So you can do it this way. And you know this father is 6 times as old as John. So, which means that the father has to be 6 units. So this is how you represent the model. Okay. Another alternative way to represent the model, you can also same thing. John is 1 unit, 5 years old. The father is 6 times, so you draw 6 units. 1, 2, 3, 4, 5, 6. This is another way of representing the model. How you represent each one is actually your preference, but sometimes there's some advantage of representing it this way, although it looks more tedious. But visually, the impact is there, okay, which I will explain to you later. So same thing, what can we derive from the model? We know there's a difference of 5 units straight away. Okay, if you look at this question, you won't know that there's a 5 unit difference. Okay, but there's a difference of 5 units. You know that total there are 7 units. So, and you also know that 1 unit is equal to 5. So if 1 unit is equal to 5, you know the age gap is 5 units. So 5 times 5 is 25. The father's age is 6 times, so it's 6 units. So it's 30. The total age is 7 units, so it's 35. So same thing, from one simple statement, the moment you draw the model, you can get a lot of information out of it. Okay, next we move on to some real life example. Now this is a simple question. John is now 5 years old and his father is 6 times as old as John. Okay, that was what we draw just now. The question now asks is what is their age, total age in 10 years time. So which means 10 years later, what is their age? So you know their current age. John is 5 years old. The father is 6 times. Okay. So a lot of us will tend to say, oh, 10 years time. So I add 10 here because the father will add 10 years. John will add 10 years. Okay. If you notice, if you draw the model this way, it can't tell you a lot of information from here because you cannot derive what is in between here. Okay. So this doesn't really give you a lot of information. Similarly, if I say is that both of them are going to add 10, okay, and oops, sorry, okay, if I know that both of them is going to add 10, okay, but if I put all on the left side of the bar, okay, it becomes very different. It tells me straight away that, okay, if I draw the model, it straight away tell me that, oh, there is a age gap of 5 units, and each unit is 5. So, yeah, I want to find their total age. I know their total age is 1, 2, 3, 4, 5, 6, 7. Total 6 plus 1, 7 unit. I know each unit is 5. I can get straight away is 35. And I know their total age. You need to add a 10 here, add a 10 here. So their total age is 35 plus 10 plus 10 is equal to 55. And I can get the answer this way. As compared it to you draw it this way, you can't really tell much information from here. Although you can say that yes, it's 5 unit and this is 6 unit, so you know there is 7 unit, but visually you cannot see as clear, which later I will show you another example why I do it this way. Okay, let's move on to the next example. Okay, now we change the question a little bit. Now John is 5 years old and his father is 30 years old. So we know John is 5 years old, the father is 30 years old. In how many years' time John's fathers will be 2 times John's age? So now we know that he's now 6 times John's age, which is 30 years old and 5 years old. But in how many years' time? Let's say call it Y. He will be 2 times his age. So similarly, if you draw it this way, where you add the unknown at the back, and you say that, oh, I add this bar, then I know that this is 1 unit, this is 1 unit, this is 1 unit, so this is 2 times of this. There's no information that you can find anything about here. You cannot say that Y plus, oh, I don't know what is this position here. Okay, so it doesn't give you a lot of useful information. But if you draw the model this way, y and y similar, okay, then you know that this is 30, this is 5. You know that this is because it's going to be 2 times, so this is 1 unit, this is 1 unit. Straight away you can see that, hey, my 1 unit is actually 30 minus 5, which is 25. So 1 unit is 25. So in how many years time John's father age will be 2 times John's age? Okay, so you know that this is 25, this is 1 unit. Y plus 5 is also equal to 1 unit, which is equal to 25. So y is 20. So the answer is in 20 years time, John's father will be 2 times John's age. You see the difference of adding it, putting the same information on the left, and they put the same information on the right. This is in model, you try to make it the same so that you can do comparison. Okay, so let's move on. Okay, now I'm going to show you a series of questions. Okay, so for example, first one, this is taken from your P5 5A workbook. Okay, Mr. Lee is 56 years old. His new nephew, Sam, is 4 years old. In how many years' time will Mr. Lee be 5 times as old as his nephew? Okay, if you want to, my suggestion is you pause the video here and see if you can solve it. I will show you the answer on the next slides. I will pause here for 5 seconds. Okay, I hope you have solved the answer. So let me show you if you did not succeed. Go. Mr. Lee is 56 years old, so we draw a bar of 56. The nephew is 4 years old, so we draw a bar of 4 years. This is what we know. In how many years' time will Mr. Lee be 5 times as old as his nephew? So same thing, both their age will increase at the same rate. So I add a y, I add a y. Remember, I always add on the left. And you want to know Mr. Lee is 5 times as old as his nephew. So this is 5u and this is u. So the u include the current 4 years old plus the unknown year. So this is u, this is 5u. Straight away the model will tell you that this is 4u, this is u. Visually, same thing. Remember, model is about visual. Visually, you can straight away see that 56 minus 4 will give you 4u. So 4u is equal to 56 minus 4 is equal to 52. U is 13. So if this u is 13, visually you can also see that u is equal to y plus 4. So y plus 4. So y has to be 9. So in 9 years' time, Mr. Lee will be 5 times as old as Sam. So you see the power of model. Okay, so if you got it right, let's do the next question. Same thing. Royce is now 4 years older than Eric. 5 years ago, Royce was twice as old as Eric. How old is Royce now? Same thing, you can pause the video here and see if you can solve it. I will show you the answer in 5 seconds later. Okay, I hope you managed to get the answer of 13. Okay, let's do it together. So Royce is now 4 years as old as Eric. So we do not know, okay, anything. So we just draw a bar. Okay, we just draw an orange bar with regards. What is it? We just know that their difference is 4. That's all. Okay, so 5 years ago, okay, he was twice as old as Eric. Okay, so which means that 5 years ago, so 5 years ago, you can add 5 on both sides. Okay, so what they are telling you is that this is the long bar, this is a bar, there's a age difference of 4 units. So 5 years ago, if you take away 5, you draw it here, this is 1 unit, this is 1 unit. Okay, so you see the difference. This is their current age. Or as I said, all you need to know is that they have a difference of 4 based on this. I draw a long bar, I draw a short bar, and I know that there's a difference of 4. Then you say 5 years ago, I cut out both sides, and you know that this difference is actually 2, and this is 1, because Royce was 2 as old as Eric. So based on this straight away, visually you can see that this is 1 unit, this is 2 unit. This has to be equal to 1 unit. So U is equal to 4, 2U is equal to 8. And what is Roy's age? Roy's age is 5 plus 2U is 13. Straightforward. Okay, now let's do another 1 or 2 more questions. 16 years ago, Peter was twice as old as his brother. Okay, so their total age is 38 years. Find Peter's age. Same thing, you can pause the video here, or I will start again in 5 seconds. Okay, so 60 years ago, Peter was twice as old as his brother. Okay, so that is before you add the word 16. He is twice as old as his brother. So this is Peter, this is his brother, twice as old. Their total age, present age is 38, which means that you need to add back the 16. So all he's saying that this long bar plus this short bar here is equal to 38. Finds Peter's age. So now you know that 16 plus 2u, 16 plus u, add up must be equal to 38. So 32 plus 3u is 38, 3u is 6, and u is equal to 2. Okay, so Peter's current age is 16 plus 2u, so it's 16 plus 2 times 2 is equal to 20 years old. Same thing, you notice I add the age, the year on the side. Let's move on to the next question. Okay. Ken has 3 times as much money as Joy. They each spend an equal amount of money. Then Joy had $12 left and Ken has 4 times as much money as her. How much did they spend in total? Okay, this question looks like totally different from those in front, because those in front is all about age, but suddenly we come up with money. So how do we solve it? I'll pause here for 5 seconds. Okay, so the question may look like money, but actually if you look it properly, they each spend an equal amount of money. So which means that it's similar like age. Okay, both they are spending exactly the same. So there is no difference. If now they say Ken spend more and Joy spend less, then there is a difference. But because they are spending equal amount of money, the way to do is exactly the same as if they are age. Okay, so Ken has 3 times as much money as Joy. So this is Ken. I draw a long bar. It's 3 times as much money as Joy. So if this is T, this has to be 2T, 3 times. Okay. Then Joy has $12 left. Okay, first they spend an equal amount of money. So I cut away. They spend it, they spend. Okay. And Joy has $12 left. So which means that this part is left with $12. And Ken has 4 times as much money as hers. That means if this is $12, this has to be $48. Why? Because it's 4 times. Okay. So here to here is 48. Here is 12. Okay. The question asks how much did they spend in total? Okay. So the total is 2u. 1u, 2u. From the model, visually, straight away you can also see that 2t is equal to 48 minus 12. Correct? 48 is here, 12 is here, so 2t is 48 minus 12 is equal to 36 and t is 18. So the moment you know t is 18, this is t. U plus 12 is equal to t. So u plus 12 equal to t. U will be equal to $6. Okay? So 2u is $12. So each of them spend $6 and they spend $12 in total. You got it? It looks like a totally different type of question, but actually it's the same as the age because they spend an equal amount of money. So the difference is always constant. So for this type of question, as long as you see age and equal amount of money spent or equal amount of water that's being poured out, okay, the difference is always constant. So we call this type of question constant difference problem. Okay. As I said, if you find this format of video useful, do let me know by giving me a thumbs up in the video, or you can provide your comment below on how can I improve it. And if you can, you also subscribe it so that because when I release the second video, at least you get to know it. So I thank you for your support, and I will continue to do the next video after reading your comments. Thanks.